Hello friends, in this video we will be having more problems on transient analysis. Question number 1 is now appeared on your screen. In this problem, you have to determine IL of t at t equal to 1 second. As you can notice, IL of t is nothing but current flowing through the inductor. So let's begin how to go with this problem. See the supply voltage given. As you can see, your Vs supply is 3 volt before t less than 0 and for t greater than 0 it is 6 volt. So I can just note it down. This Vs supply with respect to time it is given. So Vs it's simply 3 volt for t less than 0 and Vs is 6 volt for t greater than 0. It means even in this problem, like previous problems you must have seen, there was no switch, right? But still your supply will as if act as a switch here. So let's see what happens for t less than 0. You shouldn't forget the aim to come at t less than 0. It is just to find initial conditions. And what are initial conditions? I0 and V0. I0 for inductor and V0 for capacitor. So let's see what is there in this problem. As you can see, there is an inductor. So our ultimate aim is to find I0. So for t less than 0, you can say that Vs was 3 volt for a long time. And therefore, it will reach to steady state. So you know the fact that at steady state, inductor becomes short circuit. So when inductor becomes short circuit, what is going to happen? Let's draw the circuit. This is 1 ohms. Supply voltage can be replaced with 3 volt because we are drawing it for t less than 0. After that, at a parallel branch, there is 1 ohms. Parallel to which now inductor is replaced with short. And this is 1 ohms. And this current we are interested to find, that is I0, right? Now how to find this I0 current? I would rather say this is like a normal DC problems. If you are comfortable with finding DC currents or DC problems, then it is very easy to find this I0. Now what I'll do is, suppose if I get a total current, then it will be easy for me. Let's say total current is IT. How to get total current? It's very simple. Total current means a current which is coming through the battery. So as you can see, this IT is a current coming through the battery. I can say it is a total current. So total current can be calculated by normal Ohm's law, voltage divided by R equivalent. So as you can see, 1 ohms and 1 ohms are connected in parallel. Effective is half. This half ohms comes in series with 1 ohms becomes 3 by 2 ohms, right? So I can say that IT is equal to 3 volt divided by 3 by 2 ohms. So this 3 gets cancelled. So can I say it is 2 ampere? Meaning that the current coming at this point is 2 ampere or coming at this node is 2 ampere. As you can see, the current is getting divided into 2 resistance and fortunately these 2 resistance are equal. So current will get divided equally, meaning that this I0 becomes how much? This I0 becomes half of 2 ampere, which is nothing but 1 ampere. So please remember, our ultimate aim to come at t less than 0 interval is just to find an initial condition. So let's go ahead and solve the problem. Now we are talking about at t equal to 0 plus. You know the fact that at t equal to 0 plus or at any time interval, your resistance never changes the behavior. The one who changes the behavior are nothing but inductor and capacitor. In this problem, there is an inductor. You know the property of inductor. It opposes change in current. Therefore, it will try to maintain same current as previous. And in order to achieve that, your inductor will act as a current source, right? So your inductor will act as current source. Let's draw the given circuit. It was 1 ohms. This time, if you notice, I'll make it 6 volt now. Because you know the fact that the supply voltage was 6 volt for t greater than 0. After that, there was one more resistance in parallel. Let's say 1 ohms here. Then inductor will be replaced with current source of 1 ampere. Is that right? Can I say this is nothing but your current through inductor t equal to 0 plus. So I can say this IL of 0 plus is 1 ampere. Am I right? Next, at t greater than 0. So we know the fact that at t greater than 0, we got a straightaway equation, that is IL of t, it's simply ISS plus k into e to the power minus t by tau. Let me say this is equation number 1. You know the fact that we follow sequence: steady state current first, finding k, and then finding tau, right? Now to find ISS, what ISS stands for? Steady state current, and steady state current is always found at t tends to infinity. So at t tends to infinity, you know the fact that inductor will act as short circuit, and the effective circuit will be like this: 1 ohms, this is of course 6 volt, this is 1 ohms, inductor this time replaced with short circuit, again this is 1 ohms, and this time the current through this inductor is known as ISS, that is steady state current. Am I right? How to get steady state current? For example, again, if I calculate IT, how to get IT? IT is simply total voltage 6 divided by total impedance or total resistance in this case, which is 3 by 2, which comes out to be 4 ampere. So your ISS, suppose this is 4 ampere, so you understand it, this current are getting divided equally because of the equal resistances, so ISS becomes 2 ampere. So now we have the value of ISS, we can substitute in equation number 1. IL of t now becomes 2 plus k into e to the power minus t by tau. Now to get k, you know the fact that to get k, what we do? We substitute t equal to 0. That is nothing but 0 plus. Now the question is, do we know the value of IL of t at t equal to 0 plus? Of course we know that. We have already calculated at this place, right? So now we can substitute IL of 0 plus as 1 ampere. So at this place, I'll substitute 1 is equal to 2 plus k into e to the power minus t by tau. I'll say this equation as 2. So go ahead and solve this further. So solving this further, it was 1 equal to 2 plus k into e to the power minus t by tau. The same equation I have copied. You know the fact that actually t equal to 0, so this power will become 0, which results in k equal to what? Minus 1. So now we have k equal to minus 1, so now we can write IL of t, it's simply 2 minus e to the power minus t by tau. Now to get tau, you should have equivalent circuit for t greater than 0. So you know the fact that at t greater than 0, you had this circuit. So in this circuit, we can just separate out this inductor. To get tau, you know the fact that tau is nothing but L by R. So your L is 1.5 and R is R equivalent. How to get R equivalent? You know the fact that we replace voltage source with short circuit. So if I short circuit this, as you can see, this 1 and 1 comes in parallel. So effective becomes half. This half will come in series with 1 ohms. So R equivalent, as you can see, it is half plus 1, which is nothing but again 3 by 2, which is nothing but again 1.5 ohms. Effectively, tau is 1.5 upon 1.5, so it becomes 1 second. Let us substitute this tau in equation number 3. Finally, we have IL of t equal to 2 minus e to the power minus t. So this is equation 4 for me. Let us summarize the question. The question was to determine IL of t at t equal to 1 second. So at t equal to 1 second, you should actually substitute t equal to 1 here. Effectively, IL of t will become 2 minus e to the power minus t. You can just substitute these values in the calculator, you'll get 1.636 ampere. So this is the final answer. IL of t at t equal to 1 second is 1.636 ampere. Let's move to the next problem. A series RC circuit is connected to DC voltage source at time t equal to 0, the relationship between voltage source Vs, resistor R and capacitor C of I of t is given as Vs is equal to R into I plus 1 upon C integration 0 to t I of dt. Then identify the valid response of I of t, and 4 options are given. Let's move to the next slide to see what 4 options are given. These are the current responses given. You have to identify the correct current response. We'll exactly try to understand what the problem is about. See, this is a series RC circuit. In fact, the circuit is not given. Let's draw that circuit. It's a very simple RC circuit given. And they say that it is connected to a DC excitation or DC source at time t equal to 0. Means we can now connect a switch. And let's say supply voltage is Vs and this switch is closing at t equal to 0. So now according to the problem statement, now it is going to satisfy this DC voltage source at t equal to 0 is connected to series RC circuit. Am I right? The relationship between voltage source Vs means this, resistor R means this, and capacitor C is this, is nothing but this. Actually, they have applied normal KVL here. You know the fact that your Vs is nothing but VR plus Vc. I'm sure you understand this. I mean, supply voltage is equal to voltage across R plus voltage across C. VR is nothing but voltage across R, which is nothing but IR, right? And voltage across C is given by a perfect formula, that is integration formula 1 upon C 0 to t I dt. So that's nothing but they have given KVL relation. That wasn't necessity for our problem. You have to identify the valid response for I of t. Let me say this is I of t. So let's see how we can go about it. Can I say I of t in general given as ISS plus k into e to the power minus t by tau, right? The first step is to get ISS. We substitute t tends to infinity. Am I right? Once we substitute t tends to infinity, then observe the circuit. At t tends to infinity, capacitor will act as what? It will act as open circuit. Tell me, if the capacitor is acting as open circuit, can I say overall circuit is open circuit? And if the circuit is open circuit, what is the current will flow that through the circuit? Of course, 0. So can't I say ISS is straight away 0 ampere because of the open circuit? Let's say this is equation number 1. I can substitute ISS equal to 0 ampere in equation 1. I get I of t equal to k into e to the power minus t by tau. Now this becomes equation number 2. Now to get k, we substitute t equal to 0. In fact, 0 plus. So as you could see, what we can do is we can substitute t equal to 0 plus. At t equal to 0 plus, try to get I of t. You know the fact that what was the voltage on capacitor before t less than 0? As you could see, at t equal to 0, switch is closing. Meaning that for t less than 0, switch was open. If the switch was open, ask yourself, do you think your capacitor was getting charged? Answer is no, it wasn't getting charged. If it wasn't getting charged, can I say that V0 was 0 volt? It means initial voltage on the capacitor was straight away 0 volt. So even after switching, as the property of capacitor that opposes change in voltage, therefore it will try to maintain same voltage as previous. To maintain this 0 volt, it will act as short circuit at t equal to 0 plus. So at t equal to 0 plus, we know the fact that capacitor will act as what? Short circuit. If it is acting as short circuit, what does that mean? It means the circuit will be like this, plus minus Vs. This is R, and there is nothing now because capacitor is replaced with short circuit, and this is I of t. So what is I of t by Ohm's law? I of t, it's simply Vs by R. At what? At t equal to 0, or you can say 0 plus. I can substitute these two things in equation number 2. Just check it out. This is equation number 2 I'm talking about. This is equation number 2 I'm talking about. Let's substitute I of t is equal to Vs by R in equation number 2. So Vs by R is equal to k into e to the power 0. Am I right? So K becomes what? K becomes Vs by R. So I can now substitute it and I can write final equation for I of t. It's simply Vs by R e to the power minus t by tau. And you know very well what is meant by tau. Tau is nothing but your time constant, and time constant is given by R into C. So it's just a constant. If this is happening to be I of t equation, we will try to plot I of t with respect to time. See, I of t with respect to time. We'll start with origin, means t equal to 0. Imagine at t equal to 0, wherever there is t, substitute with 0. If I substitute in this expression, what will happen? It will become e to the power 0, that will becomes 1. It means I of t is simply what? Vs by R. So Vs by R will be somewhere here. This is initial value. Try to identify what is a last value, that is final value. At final value, you will substitute t tends to infinity. Try to substitute t tends to infinity in this equation. In above equation, if you substitute t equal to infinity, it will become e to the power minus infinity. You know the fact that e to the power minus infinity is what? 0. It means this current will become 0 when t tends to infinity. It means since it is exponential part, it will not become 0 instantly. It will become exponentially 0 like this. In fact, you should understand that when it is a negative exponential, the curve is negative exponential. If it is a positive exponential, then only curve will go like this, positive exponential. So now try to match the obtained current I of t with all the 4 options. What you are going to get? Of course, it is matching with option number A. So option number A in our case is the correct option. Let's move to the next problem now. Question number 3 is now appeared on your screen. They are asking you the value of V naught of t at t tends to infinity. So as I said earlier in the previous videos, when it comes to t tends to infinity, you don't have to think for initial conditions, because irrespective of initial conditions, you know the fact that capacitor acts as open circuit and inductor acts as short circuit when t tends to infinity. So let's see, when it comes to t tends to infinity, your inductor will perfectly act as short circuit. In that case, this is simply 10 ampere. Why I can take this as 10 ampere? Of course, because it is 10 times u of t. You know the fact that 10 times u of t means the response will be like this. This 10 ampere, this is 0, and like this. So even though t tends to infinity, I of t will have value as 10 ampere. So I replace with 10 ampere only. As you can see in the figure, now inductor is replaced with short circuit here. Voltage across 5 is V naught, and we are asked to find V naught only at t tends to infinity. So by KCL, I can say this node can be taken as V naught, and by KCL, we can do all current additions equal to 0. So by KCL, as you can see, 10 ampere is incoming, so I can take minus 10 plus V naught minus 2ix, I'm talking about a middle branch, V naught minus 2ix whole divided by 5 plus V naught by 5, and that's whole equal to 0. As you can see, LCM is 5, so I can say minus 50 plus V naught minus 2ix plus V naught equal to 0, right? Then V naught plus V naught will become 2V naught minus 2 times Ix equal to 50. Now the question is Ix. Where is Ix? Observe Ix carefully. Ix is the current which is flowing through this branch, am I right? So at t tends to infinity, if I say this is Ix, then Ix is simply V naught by 5. So further I can write 2V naught minus 2 times V naught by 5 equal to 50. So it is 10 V naught minus 2 V naught equal to 250, which comes out to be 8 V naught equal to 250. So now you will have V naught equal to 250 divided by 8. Which comes out to be 31.25 volt. So in this problem, they asked us to calculate V naught at t tends to infinity. So what we did, without really pre-assuming all the initial conditions or ignoring initial conditions, we directly went for t tends to infinity. In previous videos, we have solved such problems where t tends to infinity comes, you don't have to really go for initial conditions. So I have directly calculated V naught at t tends to infinity. So when they say determine V naught at t tends to infinity, it is simply 31.25 volt. Let's move to the next problem now. Question number 4 is now appeared on the screen. I of t response is given. As you can see, it is valid from 1 second to 2 second, means I of t is non-zero between 1 second to 2 second. It is equal to 8 ampere. After 2 second it is 0. Before 1 second it is 0. In signals and systems, this signal is called as a gate signal. So it has got a standard name. It is nothing but a gate signal. Fine. Let's read out the problem. You have to determine Vc of t for t greater than 2. Let's read the problem statement. A current I of t shown in the figure is passed through capacitor 1 farad. The voltage across capacitor for t greater than 2 equal to is. Means, let's say this type of current, let's say pass through the capacitor. That capacitor had a value as 1 farad. So definitely, if you pass some current through the capacitor, capacitor is bound to get charged. And let's say it gets charged to Vc of t, that is voltage across capacitor at t. So when it is getting charged, you see that the voltage is continuously changing. At some given time, at steady state, it will reach to a steady state value. But what they are asking you the voltage across capacitor for time greater than or equal to 2. Let's see how to deal with this problem. Voltage across capacitor is given by simple formula 1 upon C integration I of t dt. Am I right? This is voltage equation for capacitor. Suppose if the current is known to me, having integration of it will give me a voltage. Let's see what current is given. The current is given like this. This I of t is given like this. 1 second to 2 second, it is what? 8. By using signals and systems concept, I can write I of t as 8 times u of t minus 1 minus 8 times u of t minus 2. So you must be wondering how I have written this equation. So I'll make it more elaborate to you. See, try to understand this. This is simply u of t, right? Suppose if I say 8 times u of t, what does that mean? This amplitude will become 8. Is that right? Response remains same, amplitude becomes 8. Suppose if I say 8 times u of t minus 1, what does that mean? Minus 1 indicates delaying the signal. Whenever you delay signal, in terms of time, you always shift your signal to the right hand side. Please remember, whenever you say minus 1, it is delaying by 1. When you say plus 1, it is advancing by 1. When you advance it by 1, shift your signal to the left. Otherwise, shift your signal to the right when it comes to delay. So when it comes to 8 times u of t minus 1, it's like this. As you can see, the same signal is shifted to right by 1 unit. Now suppose if I have signal called as 8 times u of t minus 2. So referring to the original signal, it was starting with 0. If I delay it by 2 intervals, amplitude will remain same. Only thing is it will start with 2. Am I right? Now, suppose from this I am getting signal called as minus 8 times u of t minus 2. Now what is going to happen? See, the same signal, it's now getting multiplied with minus 1. If it is getting multiplied by minus 1, then amplitude becomes negative. Here amplitude was positive 8, right? Now multiplying with minus 1, amplitude becomes minus 8. Again, starting with 2 only, but will have magnitude as minus 8. Is that right? Now, suppose if I add these two signals, that is signal 1 and signal 2, then what is going to happen? See, this is 0. This is, let's say, 1. So this is 0, this is 1, this is 2, and so on. See, from 0 to 1. 0 to 1, signal number 1 is having 0 value. Even signal 2, 0 to 1, it is simply 0 value. 0 plus 0 will be simply 0. Am I right? Let's see what is there from 1 to 2. As you can see, from 1 to 2, it is 8. In fact, it is 1 to infinity, it is 8. And from 1 to 2, the below signal is simply 0. So 8 plus 0 will be 8. So it will go to 8. This is up to 2. But after 2, what is happening? After 2, this is minus 8. And even after 2, it is plus 8. So plus 8 minus 8 will become 0. So this will straight away come to 0. And this becomes a gate signal. As you can see, our I of t was having this type of signal only. So I can write I of t as summation of two signals, signal 1 and signal 2. That is 8 times u of t minus 1 minus 8 times u of t minus 2. This is in fact called as a standard gate expression, a standard gate signal expression in terms of step signal. I'm sure you have understood these basics. That's the reason why you can see that I of t expression I have written the similar way. So now if such signal is, let's say, passed through capacitor having 1 farad value, they are asking you what is Vc of t for t greater than or equal to 2. Let's go for it. If the current is known, that is I of t, and if I substitute in this expression, I'll get Vc. So now Vc, it's simply 1 upon c integration of 8 times u of t minus 1 minus 8 times u of t minus 2, and this with respect to t time. So now we'll see how to go about it. So Vc of t, as we have written, now we can separate these two integrations. 8 times u of t minus 1 dt minus 8 integration of u of t minus 2 dt. We can take 8 common from both integrals. U of t minus 1 integral is r of t minus 1 minus integration of u of t minus 2, it's simply r of t minus 2. Final Vc of t becomes 8 times r of t minus 1 minus 8 times r of t minus 2. Now let me tell you what is exactly mean by r of t. Please remember, r of t stands for ramp signal. This is what we call as ramp signal, which starts with 0. And integration of u of t, it's simply r of t. You know the fact that u of t is this signal, r of t is this type of signal. So by using similar concepts, let's say if I want to go about it, 8 times r of t minus 1. What is meant by 8? 8 is nothing but a slope. So suppose if I try to draw this, it is delayed version, so it will start with 1. It is like this. The slope value is 8, right? So this value can be expressed like this. It is having negative slope starting with 2. So it will be like this, negative going slope minus 8. Please remember, when the line is going upward, it is always having positive slope. When the line goes downwards, it is always having a negative slope. What if these two signals are added, right? I'm saying it is addition because I have already compensated negative sign at slope, right? So now after addition, we'll get a signal like this. So it will start with 1. The line will grow like this. But at 2, what is happening? See, after 2 to infinity, first signal is having slope as positive 8. And here, right from 2 to infinity, the slope is having negative slope, which is minus 8. When you add two ramp signals, their slope gets added. So 8 minus 8, slope will be how much? Of course 0. And 0 slope means horizontal line. It means from 2 onwards, it will simply horizontal line. So this is nothing but your addition of two voltages. What was the slope of this? 8. What is meant by slope? Slope means change in y upon change in x. So if change in x is 1, change in y will be obviously how much? 8. It means this will be simply 8 volt. So what they are asking you, the value of Vc of t after t greater than 2. That is t greater than 2, as you can see, it is this period. So within this period, what Vc of t you find? Of course it is 8 volt. So Vc of t, it's simply 8 volt forever In fact, t tends to infinity. So this is our final answer. I'm sure you have understood this problem. Let's move to the next problem now. Question number 5 is displayed on your screen. Determine d square I by dt square at t equal to 0 plus. It is series RL circuit, right? And some options are given. Let's see how we can deal with this. See, at t less than 0, what is happening? At t less than 0, switch was open. If your switch was open, you can see that your supply was disconnected from series RL circuit. In fact, your inductor wasn't getting charged. The whole motive to come at t less than 0 is just to see initial condition. Can I say that initially inductor was uncharged, means I naught was 0 ampere? Of course, yes. Moving ahead. At t equal to 0, what is happening? At t equal to 0, switch is closed. Part C. At t equal to 0 plus. So let's see what is happening at t equal to 0 plus. At t equal to 0 plus, inductor will try to maintain same current as previous. And to maintain the same current as previous, it will act as open circuit because the previous current was 0 ampere and 0 ampere means open circuit. So inductor acts as open circuit. So there is absolutely no need to draw an equivalent circuit. If inductor is open circuit, I can directly write I of 0 plus is equal to 0 ampere. Is that right? Let's see part D. At t greater than 0. Please remember, at t greater than 0, inductor acts as inductor, capacitor acts as capacitor. Very simple to remember. So let's see. It is just a RL circuit here connected to supply, let's say V. The current flowing through this is I of t. Is that right? Now because of this current, there will be voltage drop in this polarity. Let's say this voltage is VR. Let's say this voltage is VL. So by normal KVL, can I say that supply voltage V is simply VR plus VL? I'm sure you understood this. Supply voltage V, VR is nothing but voltage across R, which is given by Ohm's law, which is of course I into R, plus VL is nothing but L into di by dt. What they are asking you actually d square I by dt square. To get d square I by dt square, first of all di by dt should be known. So what I'll do, I'll name this as equation 1 and I'll try to get di by dt first. That is L into di by dt. I can write it V minus I times R. Or I can say that di by dt is simply 1 upon L times V minus I times R. Is that right? I want di by dt at t equal to 0 plus because they are asking you d square I by dt square at t equal to 0 plus only. So I can now write di by dt at 0 plus is equal to 1 upon L V minus I of 0 plus times R. You know the fact that I of 0 plus was 0, right? So if this is 0, I can say di by dt at 0 plus, it's simply V by L. Fine. I'll say it in Roman 1. Since we want d square I by dt square, we need to redifferentiate equation number 1. So redifferentiating equation number 1, as you can see, at left hand side, it was a supply voltage. So what is supply voltage derivative? Of course, being constant, derivative of constant is 0. So left hand side becomes 0. It is equal to I into R. The derivative becomes R into di by dt. Plus L becomes constant and it becomes d square I by dt square. So L into d square I by dt square is equal to minus R times di by dt. Or I can say d square I by dt square is simply minus R upon L di by dt. I can say d square I by dt square at 0 plus it's simply minus R upon L di by dt at 0 plus. So do we know the value of di by dt there? Of course yes, it was V by L. So I can substitute V by L. So minus R by L into V by L. That becomes your d square I by dt square at t equal to 0 plus. Finally, d square I by dt square at 0 plus becomes minus RV upon L square. So this is the final value. Here d square I by dt square will have unit as, you can see it is I upon t square. I have got unit ampere and t square is nothing but second square. So the unit is ampere per second square. Let's move to the problem and we will see which option is correct. The option that we have got minus RV upon L square, actually answer, we will see what is the correct option. So as you can see, option number D here is the correct option. I'm sure you have understood all the problems. Thank you.